To wrap up volume 1, we're going to use the panel frames from the attractor exercise to create panel frame types, visualize those panel frame types using color mapping, and create new panel frame systems to include solid panels. To get started, from the remap operation, you'll notice that the values that defined the panel frame thickness, let's visualize that, contained numbers that we can't really construct with. So let's round up these values in a way that we can properly identify panel 1 has a depth of 6, for instance. Maybe panel 2 has a depth of 9, so more rounded numbers relative to the number of panels that we want to have. To do that, we would use a range, and the domain we're going to feed in is the domain that defines the minimum and maximum value we're willing to go with for the panel thickness, and the step is going to define the number of panels we want to have. So let's just do a slider from 0 to 10. Okay, I'll connect that here. Let's see what we get out. Alright, so I'm going to subtract. Remember that each step, because each step is counted, it's giving us like 5 items instead of 4. So I'm just going to do a x minus 1. Now we have 4 values. Okay, as we increase this, we still have some weird decimal values. So what I'm going to do is make this an integer. Okay, and now we have more rounded numbers here. These are going to be our panel type dimensions that define the frame thickness. The other thing we want to do is we want to divide this domain relative to the number of panel types we have. So we divide domain, so divide this domain by this number, and what we have is a list of domains that go from 6 to 24, but it's divided in 6 places. So 6 to 9, 9 to 12, and it just keeps going that way. That's how you divide domain. The reason we want to do that is we want to find from this number list, okay, which number is in this domain. This domain defines our panel frame thickness domains for the 6 types of panels that we have. We're going to find domain, and the domains we feed in here are this, and the numbers we feed in here are this. Okay, and what we get are index values. It tells us that, let's delete this, this value here, the first value, is in index 1 here. Okay, so this is in this, 6 is definitely in this, so that's why we have 0, 0, 0. Okay, now with that we can get the corresponding item in this list using this index. And what that means is that as we start to control the number of panels we have or we want to have, it categorizes these values relative to these values. Okay, and so 9, which is here, isn't here, but 9 falls within the domain which has an index 1, and 1 represents 11, and that's why we have an 11 here. So basically this operation allows us to rationalize these numbers into panel type groupings. What we're going to do now is create panel colors to correspond to the new panel thickness dimensions that we have. To do that, we do a gradient, and the lower limit will be the minimum allowable panel frame thickness, and the upper limit will be the maximum thickness, which we get from our values here. And the new parameters we feed here will be these new numbers. Also, what we're going to do is feed these new numbers into our distance. Okay, and then custom preview. Put this here. Put this here. Okay, so now you see that we have 5 panel types. So we adjust this to 2. Notice that we have only 2 panel types, signified by the color, but also signified by the dimension. The color just allows us to see it visually. So this is when we have 8, 6, 1, 2, 3, 4, 5, 6, all with different dimensions and different colors. Okay, so we have that. This, we can make all sorts of adjustments to this, and it also applies to whether we want to use the points or the curves. Okay, control the fall off. So let's keep it as the curve. Now we have standard panels that we can communicate, for instance, with the fabricator, whoever is going to build this thing. The next thing we want to do is create a new panel system by including solid panels. So we want like some of these to be solid. This is just hypothetical. To do that, we're going to use a random reduce component. Okay, so let's do a random reduce, it's right there. And we're going to connect our surface. Let's hide this. Keep our surface. Put this in here. and reduction, so we want value from 0 to 20. Let's use 30. So this is reduction value. Connect that there and hide this, and also hide the curve. Okay. So what we can see is we're reducing this list by, for instance, 20. We can do that, can randomize how it's reducing it. So for these spaces that have been created, we want to fill them with solid panels. So what we're going to do is get the index of these panels that have been removed, and we're going to use the index to get the defining curve that we're going to use to create the panel. Okay, so to do that, we do index, item index, feed our surface in here. This is the general panel list, and this is the reduced panel list. And now we have the index values of the panels remaining. So these are the values of the panels that are remaining. Okay. But the values that have been removed, in order to get that index, what we want to do is call this list. So call index. Call index is like the index list item. They just work in reverse. This gives you items at an index. This gives you items that are not in the index. So the list we want is our list of the curves that are here. So these curves, we want to feed that into the list, and then feed this index in here. And so see what's happening. These are all the panels, the curves that have been randomly removed. And so as we adjust, you would notice what's happening. It gives us those panels. So I'm going to delete this here, and then I'm going to create a surface out of those panels. Okay, now we have a flat surface. As we reduce this and jitter this, it changes. Okay, the next thing we want to do is to get the removed item index. So these items, we want to get their index, and the way we do that is we get a length, gives us the total length, and we do a series. So it's almost giving us the, goes from 0, steps 1, and give us the overall index value of this list going all the way, because we have 77 items. Okay, so if we check the length, 77. But then we want to call with this list. We want these to be the same, so this is going to give us panel. This is the index, the indices of values that have been removed. That's this. So let's do area to get the centroid, and then a tag. Location will be the centroid, the text will be this, we hide that. These items represent what has been removed. See, 0 is part of that. So that was just to check. The next thing we want to do is combine the list of surfaces with the list of reduced panel frames. And to do that, we can either insert or replace. So with insertion, let's do insert items. What we're trying to do is in this reduced list, okay, we're trying to add these items at the indices of these items. So we connect that there. So when we hide it, we notice that we have a new list that captures our changes. Okay, that's one way. The other way to do it is to do a replace, and this basically takes our overall list affected by the attractor and replaces with these items, which is the flat panels, and it swaps them at this indices. Okay, so hide this. Essentially they work the same way. We have a new list, but one we created, the other we swapped out values. We'll see how different these are. Let's apply colors or a color to the flat panel. Okay, so that means that we want to, let's use insert, or rather replace. We want to replace the overall colors here with, say, a swatch white. I want to replace it at these indices. Okay, so we have a new list. We're going to do a preview. This is geometry. Let's apply it to the first list we created. So this goes to this, but all of a sudden you see that the white is not applied to the solid panels. It's something seems to be messed up with our list. Hold that thought and let's apply it to the second one where we replaced, and now you see that the white is applied to the solid flat panels. Question is why? What happened? See the difference between a list insert or item insert item and replace item is you have your list with its item and their indices, okay, their index value, their address. When we say we want to insert into a list at a position, if we say we want to insert an item at position 1, what it does is it places that item between 0 and 1, which means the item here becomes 2 and this becomes 3 because we're placing a new 1. So it's changed the order of the lists. As opposed to swap, how swap works is you have, let's do this again, you have your list 1 indices with their items, okay. What swap does is if you want to swap at 1, it will keep the index value but remove the item and put in a new item, okay. So it keeps the existing index, the addresses of the items that are existing in this list intact. It doesn't change them, as opposed to insert, which would move it down. And so that's why when we used the replace the color with the index or with the insert item list, which is here, we had issues because this list here has been adjusted. So it's important to pay attention to that. So we're going to use this one. Even though both of them create lists, it's important to remember that what happens to my list when I use these two different methods. One pushes and disorganizes or reorders your list, while the other maintains your list and just swaps out the item. So we can do different things to this color now. Okay, just hide that. And that brings us to the end of volume 1. Modify this, okay, change the count, increase the height, you can do all of this stuff, swap points, control it with the MD slider, increase the number of random, panels removed, okay, the fall off, this is how we take advantage of lists and domains in order to operate on lists. Look out for volume 2 where we'll be talking about data trees.